All right, well, let's get started. Welcome back. How's everyone doing on day 2 of bad camp? Awake after lunch? So, let me make sure my remote is on here. So, welcome to Why Your Site is Slow. My name is Steve Persh. I'm an agency and community engineer at Pantheon. So I come from a background of having built a lot of Drupal and WordPress sites over the years. I started as a freelance developer, eventually worked with a lot of agencies building higher ed sites, media sites, a lot of nonprofit sites. I spent about half my career as a Drupal developer at palantir.net in Chicago. I now live in Milwaukee, Wisconsin. You can find me as stevector on Twitter, on GitHub, on Drupal.org. I also have Drupal haikus on Twitter, though I haven't been posting to that one all that much lately. So today we're going to be talking about the experience of making a website, and that experience that I've had a number of times. I imagine you may have had a number of times if you're making websites as well, where I'm feeling good about the site I'm making. It may feel like a mad rush to the finish, but my client is overall really happy with the site that's being built. The functionality is what the client asked for, it's matching the design, they're really loving everything, and right before launch, just as we're getting close, the client says that there's a problem. Even though that the site does what it's supposed to do, it looks the way it's supposed to look, there's still a problem. The website is slow, and 2 days before launch, a week before launch, maybe the day of launch, the client just says, can you make that site faster now that the site is fully built? Can you just, make it faster because it's great, but, it's slow. And I get frustrated when I hear something like that because there's not much that can be done to make a site fast in the last minute. There's not much you can do in the final day, in the final week, after months of working on a site to simply make it fast. Let's talk about what a website does from a high level. A website at a really high level sends a response from a server over a network to be interpreted by a client. It's really tempting when talking about website performance to get hyper-focused on the latest and greatest. It's really tempting to get focused on the latest tools and all the cool things they can do. I find it helpful to reset with the basics of website performance that have been true for decades now. We're sending responses from servers over a network to be interpreted by a browser. So in this presentation, these are the elements that we'll be looking at. We'll be looking at what can be done in that server side to make the server as fast as possible, to make that initial response as fast as possible. We'll talk a little bit about what can happen at the network level to make the internet as performant for you as possible. And we'll talk about what happens in the client, what happens in the browser. And this is really where most performance gains can be had these days. A lot of the perceived wait time for a site is actually happening in the browser. The expectations these days are that servers should be near instantaneous in their response times, and if a web page is taking 5 seconds, 10 seconds to load, that's usually time spent in the browser. So we'll be talking about key architectural points, again related to the server side, the client side, and most importantly, the underlying why. With a lot of the technical issues that we'll talk about, there's a human reason underneath that makes the technical issue difficult. It's really easy to get into a checkbox mentality when it comes to website performance, to think, I need full page caching, I need Redis, checkbox, 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 I need all these things, and yet here we are talking about website performance. If it were as easy as checking a bunch of checkboxes, we wouldn't have to have a presentation about it. We could move on to different problems. The reason that this is something still worth talking about is because there are often human reasons why these problems are still difficult to solve. So more abstractly, what a website does is have a conversation with a client. The website living on the server is having a conversation with the client, a browser. So I find it helpful that browsers can also be called clients, because that reminds me that the conversations that servers have with clients will reflect the conversations that we as web developers will have with our clients, with the people who need the website. And we'll also be talking about how websites inform the world about an organization. So if you're building a website for a store, for a store or a company that has a physical presence that sells physical goods in the real world, and that process is inefficient. If a company has a difficult time selling goods and optimizing that process in the physical world, there's a high chance they're going to have a difficult time optimizing that process online. If you're building a site for a nonprofit that has a really hard time explaining itself in person, that has a hard time defining what its mission is, defining how it's structured, that difficulty is going to manifest itself in the website in one way or another. It may be as simple as a menu navigation that doesn't really make any sense, but it could be even worse. So let's jump into the server side. So we've got the top level problem. Our client has told us that the website is too slow. And we have to ask why. And we're going to have to ask why a couple of times. That'll be the theme throughout this performance, asking why over and over again. So if the server is not responding with HTML fast enough, why is it not responding with HTML fast enough? If the expectation these days are that servers respond in a very small number of milliseconds, why is that not happening? Well, in the Web 1.0 world, the answer to that question is probably that there's a limit to how fast .html files can be read off of a hard disk. I find it helpful to remember where we're coming from. This is probably not the answer these days. We're at a Drupal conference after all. Our Drupal sites aren't reading .html files off of a hard disk, but the internet is still built with the assumption that if a client asks a website for a web page, that the response comes instantaneously or near instantaneously. So now the answer to that question, why is the HTML response too slow? The answer these days is probably something like the HTML is not in Varnish or in some kind of full page cache. So Varnish is one example of a full page cache. It's a piece of infrastructure that sits in between that public internet and the rest of your web infrastructure that's running Drupal. So requests are coming into your infrastructure all the time. People are asking for your homepage. They're asking for the about page. That client is asking the website, asking the server, tell me about yourself. Tell me about /about. Varnish is seeing that request come in all the time. And if it saw that request come in 3 seconds ago, then it can just serve out the same response immediately. It doesn't have to go back to Drupal and say, from scratch, tell me about this website. It knows immediately what that response is. It can serve it right back out immediately. If for some reason Varnish doesn't have that page, if it's asking for node 123 and no one has asked for node 123 recently, then Varnish is going to have to say, I don't know anything about node 123. Drupal, can you give me the full HTML for node 123? Varnish gets that response, passes that along to the client. So Varnish is one of many tools that can do this concept. There are others as well. So why may the URL not be in Varnish? Varnish and these other tools that do the same concept rely on HTTP headers. HTTP headers are the metadata that live with our requests and responses. So if I'm getting asked by a client for /about and I'm the server and I'm sending back my HTML for /about, I'm throwing on, as the server, I'm throwing on some metadata. Like, most importantly at the bottom here, this cache control header, which is saying to Varnish and anything else that's receiving this response, you can publicly cache this response, and you can publicly cache it for as long as 900 seconds. That max age is 900 seconds. And by the way, what we're looking at here is just a debugging tool that Pantheon provides, because sometimes people unintentionally break their Varnish cache by not realizing what their HTTP headers are doing. So without realizing it, you can break your HTTP headers and tell Varnish this is not cacheable. Even if you as the web developer don't intend to do that, you may do it accidentally. So Drupal core has some basic configuration that corresponds to these. We saw over in those HTTP headers, 900 seconds. That just corresponds to that core Drupal setting of a 15-minute page cache limit. So asking again, why is the HTML response too slow? Maybe our URL isn't in Varnish because we don't have Varnish at all. We don't have any reverse proxy cache. We don't have any CDN. And a common answer to the question, why don't we have that, is we're running on a custom infrastructure. Our organization, our university, our business says we have to host internally. We can only use our internal servers, and we simply don't have anyone on staff who knows how to set up Varnish. And there are internal political reasons that prevent us from using external infrastructure, and it's a mess. So one way I like to think about this problem is, at what number of sites does it become cost effective for you as an organization to manage your own Varnish configuration? Varnish is a somewhat niche technology in that while just about every site should use something like Varnish, not every web developer needs to know how to set up Varnish. I don't know how to set up Varnish. There are other people at Pantheon who know how to set up Varnish. I'm glad my coworkers know how to do that. We're running over 100,000 websites. At the scale of over 100,000 websites, it absolutely makes sense for us to have people who can configure Varnish. If I were working as a freelancer and managing only one site, if I were internal to an organization and managing, say, 3 sites, I wouldn't want to take my days, my afternoons figuring out how to set up Varnish. I would want someone else to be able to do that for me. I think this is an example of asking, can I make decisions that will make my team faster and my site faster? So I think if you can let someone else solve Varnish for you, it's going to make your site faster because suddenly all your page responses are getting cached by some great infrastructure. And ideally, your team is moving faster because that's one less thing for you to worry about. Some of the topics we'll talk about, especially client side, don't have that clean breakdown. Sometimes you have to make decisions that make your team slower, give you more stuff to do, but it makes your site faster. That's a trade-off that you sometimes have to balance. So sometimes the response is not in Varnish, and we do have to go to Drupal and have the full HTML built from scratch. And sometimes Drupal responds slowly. Sometimes Drupal can take 2 seconds, 3 seconds, 4 seconds to build that HTML. If you ask why, you can get all kinds of answers to why is Drupal taking so long. You might get the answer that there are too many modules, that there's too many queries, or that there are slow queries, there's too much memory being used, you've got way too many nodes being loaded, too many function calls, too many calls to the same functions. It can be overwhelming if you're just starting from scratch and asking why is Drupal taking so long to respond. Well, let's start with one potential answer. Too many queries. Why are there too many queries being run on a site? Maybe you don't know. I've certainly been in the position where 2-3 months into a site build, the site started to get slow, and I didn't exactly know why. And I started to turn on profiling tools. Like this is a screenshot of the web profiler module in Drupal 8, which gives you a report of the number of database queries being run on the given page. I think I would recommend this for just about anyone building a Drupal 8 site. Turn this on in development and pay attention to the numbers at the bottom here. Pay attention to how many queries are being run. If 1 week there are 80 queries being run on a page and the next week there are 800, you know something has gone wrong. But without some basic insight, you won't know where to start. This is a screenshot of New Relic. It's a great profiling tool to give you detailed insight into how long your site is taking to respond and what you can do about it. This particular screenshot is showing the difference between PHP 5.6 and PHP 7 as I just repeatedly installed Drupal 8 just to get a sense of the difference. So I'm not going to talk too much about PHP 7 just because that's one of the simplest things we can do right now for website performance. If you have the option to switch from PHP 5.6 to PHP 7, you get an improvement that big. So what we're seeing is that Drupal 8, the standard profile, takes about 60 seconds to install on Pantheon if you're using PHP 5.6, and significantly less if you are using PHP 7. So that's a super easy win, and with tools like New Relic, not only can you see the improvements that you're making, you can find the slow spots really easily just by looking at charts like this. So Another line of answers to the question of why is Drupal responding so slowly. Too many queries. Maybe we're loading too many nodes from the database. Maybe that's the reason why things are getting slower. The more specifically we can answer the question, why is the site slow, the more likely it is that we'll be able to find a specific tool that addresses that problem. So a lot of sites, need to load a lot of nodes or a lot of users or a lot of comments. And those are PHP objects. And if we can specifically say that the problem is lots of PHP objects are getting loaded on every single page request, then we can use a tool specifically meant to address that problem. So there's the entity cache module that's meant to address that exact problem of we want to reuse the same node objects that get loaded on every single page. We don't want to do that from scratch. So if you can pair that up with Redis, or now Lcache, a new caching replacement for Redis that Pantheon is developing, you can find performance improvements. Maybe it's not that there are too many queries, but maybe there's just one really, really slow query. And views module is often the culprit here. And that's not views module's fault, in my opinion. It's just, as Drupal developers, most of our complex or our most important queries get run through views. And views is a leaky abstraction. So what I mean by leaky abstraction is views is an abstraction layer that allows you to think less about the SQL that's actually being run. I find the more I use views module, the less I'm thinking about what actual queries are being run. I'm just thinking in terms of these buttons and these relationships between content types and entities, and it's fast. It allows me to work faster. But if I find using the views debug information that suddenly my query has jumped from executing in 1.72 milliseconds to 100 milliseconds, and you really can click one button in the views interface and change your query from executing in 1 millisecond to 100 milliseconds. If I didn't have this reporting turned on, I wouldn't even notice that. So I'm not asking you to read all this SQL here. Even when you're constructing views, you're probably not going to be reading line by line the SQL statements that are getting created. But it is a good idea to pay attention to that execution time, because when it does jump from 1 millisecond to 100 milliseconds, without this reporting, you'll have a hard time noticing if that difference is because the query got slower or just because this is a complex Drupal site and everything in the administrative side takes a second or two to load. So maybe we have too many queries, or I should say maybe we have one really slow query because we genuinely have one really complex requirement. A lot of sites have the concept of related articles. And if you can, as a group of developers or a team, clearly define verbally what you mean by related articles, if you can say that all the articles on our site have one and only one primary taxonomy term, and related articles is just a list of other articles in the same taxonomy term sorted chronologically, that's probably going to be a relatively performant query, because we as a group can agree on what that means. Our computer is going to be able to process that quickly. But if it takes 15 minutes and people disagree, and some people think related content actually has to take into account, say, whether or not there's an image on the article, and you also have to take into account the author of the article, and you also have to take into account these 5 other taxonomies, that's going to be a slower query. If these requirements take a long time to talk through, if you don't have agreement on what the requirements actually are, that's almost certainly going to manifest in a slower site. Another common answer to the problem, why is the site so slow? Oh, yeah.
So essentially you're saying, hey, the more filters you have and the more contextual references you have, you're going to slow down. Is it exponential? Or is it...
No, it's more like certain table joins will significantly slow down the query, and someone who is an SQL expert could give you a more detailed answer to what types of joins are going to make make the query slower. Me no longer feeling like an expert. Yeah. It's the relationships, and depending on, like, if you add a relationship, maybe that doesn't impact things, but then you add on a filter on the relationship, you can see a big jump in response time. Yeah. Oh shit, my bad. Wait, I gotta figure out this one. I was too excited. I'm gonna close this door.
Because you have to join back on the node table and the table. So if you have 6 columns, and 6 of those
Yeah, so for the recording, I think that the answer from the crowd there was that every time you add an additional relationship, you're creating a SQL join, and you may be joining the same table onto itself over and over again, and that can be particularly problematic. So to keep it moving here, another answer to the question, why is the Drupal site responding slowly, is that there are too many modules. And I think that is not a specific enough answer. Yes, too many modules can slow down your site. The more modules you have, the more Drupal needs to work to find out what are all the hook implementations. Every time you add a module, that's one more module that Drupal asks, hey, do you have hook in it? Do you have hook views field data alter? And that will make your site slightly slower. However, I think the problem of too many modules is more likely an indicator of overlapping or duplicate modules. If you have 300 modules installed on your site, there's a good chance that there are 2 modules that are trying to do the same thing. For instance, you may be using both Panelizer and Display Suite module for the concept of controlling the rendering of view modes. Both modules have their advantages. You can pick and choose between them, but if both are in place on a site, that's an indication that the team isn't talking with one another. And if your team isn't talking with each other, you're going to find slowness all over the site. The number of modules is just a leading indicator of poor communication in some cases. So there may be just a lack of clarity and history among the team. So with slow sites, can you treat slow like a bug? If you find out that there are duplicate modules, if there are 2 modules that are trying to add third-party analytics information to your site, can you look through tests? Or do you have a Git history where you can find out where these modules were enabled? And do your Git commit messages reference project management tickets? And you can find out, oh, at some point we had a legitimate reason for adding Display Suite, and a year before that, we had a legitimate reason for adding Panelizer, but we didn't really realize what we were doing at the time. Do you have developer documentation guiding module choice? I think especially for agencies that are building similar sites over and over again, it's really important to develop some kind of internal recommendations for why you might choose one module over the other so that you don't end up with overlapping modules. Ultimately, I think when sites are slow, when you get that report right before launch from your client that the site is slow, it's an indication that slow was not defined up front, that there wasn't a definition of expectations for performance. So why was slow not defined? There's a good chance then that the team is struggling to define lots of things up front. You may have difficulty defining user personas and acceptance criteria and testing strategies. For any site, how do you know if the site is secure or accessible, or if it behaves as expected? Do you know who's using the site? Do you know how fast it should execute? So I mentioned that I think a lot of teams will assume that in the last 2 weeks they can do a performance sprint and make the site fast. I don't think that would be a good idea for any of these other topics. I don't think you would assume that you're building an insecure site for 2 months, and in the last 2 weeks, you'll make it secure. Or it's totally inaccessible, but in the last week, we'll make it accessible. Or it doesn't really do the behavior that the client expected, and it's not really built for the audience that it's supposed to be built for, but we'll just fix that at the last minute. I don't think that's an acceptable strategy for any of these other areas, and it's not a good strategy for performance either. Moving on to the network level. So we talked server side. What about the network level? So maybe our assets are taking too long to load. We're trying to answer the question, why is our site slow? Maybe we know that the assets are taking too long to load. Maybe they're taking too long to load because each asset, each file, each image, each CSS file requires its own HTTP connection because we're not using HTTP2 yet. HTTP2 is another one of these, dare I say, easy wins, where if you have the option to turn on HTTP2, suddenly your whole site will simply be faster, because instead of all of your CSS files, all of your images being sent over separate connections per file, multiple files can be sent over one connection, and your site will simply get faster. So there is still consideration to be had for the number of files you're making, the size of the files, but independent of that, if you have the ability to turn on HTTP2, I recommend it. If each file is requiring its own connection and you aren't using HTTP2 2 yet. Maybe you can't do HTTP2 because you don't have HTTPS, or maybe you're not on a CDN. CDNs are really one of the easiest ways right now to get HTTP2 for free. To stay on that thought for just a second, about a year ago, I moved one of my personal sites to Cloudflare because I wanted the free HTTPS that Cloudflare provided. And then a few months later, I got an email from Cloudflare saying, hey, you have HTTP2 now. I thought, that's amazing. I didn't have to do anything. And suddenly I had HTTP2 because I was offloading that responsibility for my edge layer to Cloudflare, and they can handle HTTPS for me. And all at once they turned on HTTP2 and I didn't have to do anything about it. So what else can CDNs do for us? If our assets are taking too long to load, maybe it's because they are literally too far away and the speed of light is only so fast. So the basic idea behind a content delivery network like Cloudflare or Fastly is to get your files physically closer on the globe to the people requesting them. So if your primary infrastructure is in Austin, Texas, and the person requesting it is in Australia, that's going to take a long time. The speed of light is only so fast. So if you can, move copies of your images, of your CSS files, even your HTML if possible, to multiple places around the globe, your site will simply be faster for people using the site all over the globe. That was the brief network portion of the presentation. The client side, again, is where a lot of performance gains can be had right now. So what we're looking at right here is the Chrome developer tools when I visit Drupal.org. So what I'm seeing here is a list of the assets that get loaded by my browser when I visit Drupal.org as a logged in user. And again, I'm not asking you necessarily to read all this in detail. Just notice there's a fair number of files here, and it's taking nearly 3 seconds to load the whole page. Nearly 1 second of that is spent on the initial HTML because I'm logged into Drupal.org. Drupal.org can't varnish cache the whole page because it needs to do some level of personalization. So it takes nearly a second to generate that HTML. And then that HTML document is an agenda for the meeting that the server is going to have with the client. So for the client to understand this meeting that it's having with the website, it needs to download all of these assets. It needs to get some CSS files, it needs to get some JavaScript files, it needs to get a couple of images. And it's really tempting, again, to get hyper-focused on the numbers, to get hyper-focused on the latest optimizations you can do client side. This is sitespeed.io. It's one of the many tools you can use that will give you numbers and data. And it's, again, really tempting to look at a graph like this and see, oh, I see some items in red. Maybe I can have fewer JavaScript files. Maybe I can have fewer CSS files. I need to make all of these numbers smaller. And I think that is a somewhat dangerous mentality. Maybe you think, my CSS is taking too long to load, my site has too much CSS. You can come to the unhelpful conclusion that the website is fat, that these numbers are too big and they need to be made smaller. Well, Mark Drummond, a prominent front-end developer at Lullabot, has this to say. He thinks that the fat sites metaphor isn't helping us at all, because not only is it bringing all this emotional baggage to a technical conversation, it's also focusing on the wrong thing. It's obscuring what's really making this site slower. So here's a screenshot from Google's developer documentation explaining how browsers process these responses from servers. So even independent of the file size, independent of how much CSS is coming to the browser, we can make optimizations that will make the site feel faster. Depending on how we structure our CSS, depending on how we structure our JavaScript, we can ensure that the most important elements start displaying as soon as possible to the user. If we're not careful, then regardless of how much page weight is being sent, we may have our users seeing a totally blank white screen and then everything pops into place at the end. That's not a great experience. So let's try another answer at the question, why is the front end taking too long to load? So our CSS is taking too long, we have too much CSS, maybe we have unused CSS rules. And maybe we have unused CSS rules because we're afraid to edit our CSS. I've absolutely been in this position. What we're looking at right here, again, Chrome Developer Tools is giving us stats on how much CSS is not being used by the current page, broken down by CSS file. So I know one of the reasons I've gotten into this situation is because I may have not been on the initial build of a site, and then I'm helping to support the site and I get a ticket that says you need to build feature X. I build feature X. I know I need to edit a CSS file. I open up the CSS file. It's big. It seems disorganized. I'm scared to break anything. So I scroll down to the bottom of the CSS file. I write really specific CSS selectors that I hope don't break anything else. I close the CSS file and I commit it and hope no one notices that I've made the CSS even less organized than it was before. The file is bigger than it was before, and I wasn't able to refactor my CSS with confidence. Screenshotting tools are a great way to refactor your CSS with confidence. So if you see those Chrome Developer Tools letting you know that you have unused CSS rules, maybe you can delete those unused CSS rules. Maybe those CSS rules were written 6 months ago and just really aren't being used anywhere on your site. If you have a screenshotting tool that can screenshot a representative sample of your pages, go ahead and delete that CSS, run the screenshot, see if anything moves pixel by pixel, and if not, then your CSS is a little bit smaller, a little bit faster. Wraith is just one of many screenshotting tools you can use to accomplish that goal. Another answer to the question, why is the CSS taking too long to load? We're afraid to edit our CSS because it has no organization. There are lots of philosophies out there for organizing your CSS. There's smacks. What we're looking at here is a screenshot from BEM, getbem.com. Block element modifier is what BEM stands for. So what we're looking at here is just an example of GitHub. GitHub is identifying elements like our menu is one element. Then we have individual menu elements, and we even have modifiers for things like the element is a button and the modifier is green, or the modifier is that it's a size big input. So you can find really complex systems for organizing CSS. You can find simple systems for organizing CSS. My point here is that any system is better than no system. And I certainly started with no system whatsoever for my CSS, and eventually it becomes unmaintainable. The bigger the project, the more people working on the project, the more important it is that you have some system for organizing that CSS. Where is our CSS and JavaScript actually coming from, though? Yes, question in the back.
Organization contributes to what?
So having organization contributes to maintainability. Maintainability across the board results in speed. So I think one of my main points throughout the presentation is that in order to optimize a site, you have to be able to understand it. And if a CSS file is not organized, you won't be able to understand it, you won't be able to optimize it and make it faster. And you may not know where it's coming from. So where are our CSS and JavaScript files actually coming from in a Drupal site? So in Drupal 6 and Drupal 7, you had the option to globally add individual CSS and JavaScript files to every single page. Using hook init, you can use Drupal add CSS or Drupal add JS, and suddenly that CSS and JavaScript is on every single page. Even if it's only needed on the front end of your site, it's going to get loaded on the admin pages if you're not careful. Now in Drupal 8, the best practice here is enforced. The idea that was present in Drupal 7 but not enforced is now enforced in Drupal 8. You have to identify specifically what HTML elements, what render arrays, are actually related to your CSS, to your JavaScript libraries. So then you won't have the problem of loading unused CSS if you're careful about it here. So when you have lots of CSS and JavaScript files, you have three basic options. You can serve them all individually. This is what would happen if you click if you unclicked the aggregate CSS or aggregate JavaScript buttons in Drupal core. You can serve them all And usually you'll have lots of HTTP requests, but the advantage you have is that you could cache them all individually, maybe cache them each more aggressively than you otherwise would. You can package them all up into one CSS or one JavaScript file per HTML page. Then you're going to have fewer HTTP requests with each web page, but those packages probably are going to vary with every single web page on your site, or at least every single type of page. So you get one request, but poorer caching. Or you can split the difference, which is basically what Drupal core does. That's what we saw in that screenshot at the beginning of this section, where Drupal core is giving us chunks of JavaScript and chunks of CSS that are aggregated in some sort of logical grouping. I think the key question here is, where do you want to implement this decision? You can implement this decision simply by letting Drupal core handle it. Drupal core works pretty well in this respect, in my opinion. However, you may think, we want to get even more optimized than what Drupal core is going to give us. You could use a module like advanced aggregation, which gives you really fine-grained tools for managing how those aggregations happen. You could write a custom grunt or gulp file to manage how these concatenations and minifications are happening. I think the key question here is, do you really want to own this decision? Or is Drupal core good enough? I think this is a place where you do have to balance the site moving faster and your team moving faster. I think for a lot of Drupal teams out there, they're not worried about it at all. They leave the Drupal core checkbox checked, and that's absolutely good enough, and they don't spend time writing custom logic or doing custom configuration of advanced aggregation on top of what is in core. And I think for a lot of sites, that's perfectly fine. And their sites move fast enough, and as teams, they still move fast too. There's a trade-off to be considered there. Sorry about that. A lot of front-end optimizations these days have to do with JavaScript widgets that are embedded throughout your page. Why can those be problematic? Often they're adding more than is needed to your page. So with tools like grunt and gulp, again, it's tempting to think about really fine-grained techniques for concatenating, for minification, but ultimately what you need to do is audit your code and make it need less stuff. So maybe your answer to the question, why is the site slow, that there are too many third-party widgets on the page. And what I mean by third-party widgets often are those share links. You can get share links from Twitter, you can get share links from Facebook. There are even startups that just do share links. And it can be problematic. So again, from the Google developer documentation, when the browser encounters a script tag in the middle of your HTML document, it's an interruption. Again, the server is having a meeting with your client. It's having a conversation with that browser. The HTML document is one set of that conversation. A script tag right in the middle is interrupting the browser's processing of that HTML. And depending on where you're getting your share widgets from, you may be adding a number of files to that interruption, adding even more page weight to that interruption. So why might you have too many third-party widgets? I think often the answer is that no one feels responsible for them. If you as a developer have 15 tickets that you need to complete by Friday, and one of them is a share widget, and your stakeholders have said, hey, we Googled for it and we found this share widget here, all you have to do is copy paste this JavaScript code, put it into the sidebar, and I as the stakeholder will be happy. It's really tempting for the developer to just say, okay, I'll copy paste that, commit it, 10 minutes later, I'm done, on to the next task, and the site has gotten a little bit slower, a few more HTTP requests, and no one feels responsible for the performance impact that the site has because the developer just did what the client asked for. So this is an example of Conway's Law. Organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. If you have too many third-party widgets, maybe it's because you have two sets of analytics codes. Maybe you have two groups of people analyzing the traffic on your site who don't share any tools. They don't work on the same floor. They don't work in the same city. They don't talk to each other. They don't share any tools whatsoever. If you as the developer are told, make this site faster, and you say, well, we have Google Analytics, and we have Chartbeat, and we have Omniture, we have all these other things, why do we need them? And the answer is, well, we have all these people in our organization, and they need all these things. You as the developer alone can't fix that. So if you're in a meeting, are agenda items getting added ad hoc? Do you have factions who ignore one another or interrupt one another? Are you repeating topics from previous meetings? Are you starting the meeting late? I think if you're doing these things, they will manifest themselves in your website one way or another. If you have a culture that doesn't care if meetings start 5 minutes late, 10 minutes late, then there's a good chance that no one in your organization notices or cares when your server responds in 3 seconds instead of 30 milliseconds. If no one is paying attention to the fact that the previous topics from older meetings just get carried over again and again, then probably no one notices or cares that unrelated CSS is getting carried over web page to web page, even though it's not needed, not used, not providing any value. So one more topic on the front end side of things. AMP, accelerated mobile pages. Who here has heard about this? So we're running short on time, so I'll give my quick rant on AMP, but up front I want to say that if you are responsible for a site that has articles and relies on search traffic, you probably should implement AMP because you'll get preferential treatment in Google. But I still think it's somewhat problematic. Imagine it's 2004 and you have a desktop site, it works just fine, you converted it to Drupal, it's the early days of Drupal, everybody's happy, the monitor cuts out. Time moves forward, it's 2006, adding new features is easy, removing features is hard, so the site is getting a little bit slower. We've got a lot of features on our site. By the time 2008 comes around and the iPhone is out, this site is not going to work on the iPhone. There's way too many features, way too much stuff getting loaded. No way this site can run on an iPhone. We need an m.dot subdomain, a different copy of the site. Well, okay. Time moves forward, adding new features is easy, removing features is hard. These two sites start to diverge, and they become unmaintainable as they diverge further and further. So, by 2012, you recreate example.com, maybe in Drupal 7, maybe it's a responsive site, and it's great. It's mobile first, it's fast, it works everywhere. There's a sensible number of features on the site, but of course, time moves forward. Adding new features is easy, removing features is hard. So that site that was mobile first back in 2012 is not mobile forever. It's no longer all that fast on our phone. So by 2016, it's not fast on a phone at all. And AMP is out, so we add another feature. The AMP feature gets added to our site, and now we're back to having two URLs for our article pages, and perhaps even all pages, now as AMP is becoming a recommendation really for all pages, not just articles. I don't know what I expected solving the problem of too many features with another feature. I think it's kind of genius the way AMP has been positioned, because it's a way to shortcut the conversation of how can we remove these excess features from our site. We don't. We add another feature, and that feature is the removal of features, but just on a different URL. Feature creep finds a way, I think is one of the lessons here. And I think this is a warning for AMP itself, because I'm concerned about feature creep in AMP itself. AMP is super, super fast right now, but I'm worried it won't be fast forever. So when it comes to performance in general, you know you're moving in the right direction when you can describe how the website is built. I mean this both over the life of the project, if you can describe how you go from requirements conversations with your client to a functioning website weeks or months later, if you can clearly describe how that process works, you have a good chance of making a fast site. I also mean that at runtime. If you can describe what Drupal does from the time it gets a request coming in to the time it serves HTML back, you have a good chance of having a fast site. But if you can't describe that, if you don't know why you have blocks and page manager and display suite and context module, and you don't have a clear picture of how these modules are interacting with one another, if you don't have a clear understanding of where the CSS is coming from, then the site probably won't be all that performant. If you can track changes over time, you have a good chance of having a faster site. Because when you can track changes over time, you can eventually estimate the performance impact of a feature. You can say to your client, we've already added 2 sliders to the homepage, and we can see how much slower the homepage got every time we added a slider. You're asking for a 3rd slideshow on the homepage. What do you expect to happen if we add a 3rd slideshow? Perhaps then you can start your projects with performance limits, with a performance budget, with some hard cap, something that will trigger a conversation with your client so that if you exceed some load time, you know something needs to change. If you can make decisions that make your site faster and your team faster, you're moving in the right direction. And I think when performance is a boring topic, again, there are a lot of new exciting things in the world of website performance, but a lot of the fundamentals, making your server respond faster, making the browser interpret the response faster, these are well understood problem spaces that have been around since the beginning of the internet. When you can audit your CSS, that's not a particularly exciting thing to do, but it's the kind of thing that makes a site performant over a long period of time. Finally, I do want to call out a survey for diversity in the web. This is something that you may have heard of throughout the conference, as a number of speakers have been bringing it up. A group of developers are looking to put together a sample set of data to understand who is in both the Drupal community and the wider community of web developers. So thanks, everyone. And we're just over time, but I think we can take questions as long as the next presenter doesn't need to get set up. Any questions at all? Yes?
I don't know what about AMP. Can you just really briefly describe what it is?
Sure. So AMP is an alternative set of HTML. So for a given, first for articles and now for all web pages, you can render that article with an alternative set of HTML that simply has limitations. Limitations like no custom JavaScript. I think you can link out to like known AMP community provided JavaScript files. No external CSS files, I think, is another limitation. All CSS has to be inlined, and there's a cap on the amount of CSS. So it's basically a restricted set of tools, and the way it actually links up is with a link tag in the header of your normal page. So you could have a link to the canonical version of the page, you could have a link to, say, the RSS feed, you could have a link to the AMP page. So Google and other tools using AMP can read your normal HTML document and see in the header link, something like link type AMP. I forget the exact convention. But yeah, I think the question is then, once you have an accelerated mobile page, why do you need the decelerated immobile page? I think as designers get better and better at designing for AMP, like right now AMP pages are kind of visually boring because of the limitations. They're not all that exciting to look at. They just load really fast. I wouldn't be surprised if eventually more and more sites design a really great AMP site, and then that's just their whole site.
So Google indexes your pages. How does that compare to Varnish?
So Google will give you preferential ranking, or it'll respond to fast sites. It'll notice if a site responds quickly. So if your pages are Varnish cached, then the Google crawler will get that response in 30 milliseconds, including network traffic. And Varnish can respond in like 1 or 2 milliseconds compared to Drupal, which can take an entire second or 2 entire seconds. And the Google bot will notice that difference in response time and see, oh, you have a fast site, we're going to rank you better accordingly.
I think your question was like, what's the difference between Chrome caching your stuff? And that's at an individual level, whereas Varnish is sitting in a server and saying, hey, user A, can you just call the same page that user B is looking for? So I can already tell user B, and I can load user B faster.
But the Google indexed page
wrong, but I think that more is like them understanding your statement and then tagging you and like, oh, I know what's in here. I know what this content is, so that it the return responses to search.
And what about, so I have a bunch of my database stuff is indexed, and is that different than Varnish? It's indexed like a...
Oh, sure. Yeah.
We have our indexed database.
Yeah. Database indexing is a way of making your queries faster by indicating which columns in a table should be indexed by the database itself, which can make a query faster. So that's a couple layers removed from whether or not the HTML response is Varnish cached.
Is Varnish basically an indexer?
Conceptually, I suppose you could consider
It's
what's in the
more
Varnish.
a copy of your page.
Yeah.
Rendered.
Yeah.
If you have low traffic, is it bad?
If you have low traffic, then Varnish may not be doing you all that much good if you keep the max age set to 10 minutes. Like if no one comes in the next 10 minutes, then the person who comes a half hour later doesn't get any benefit from that. So that's why you could toggle those settings and just go for a really high cache lifetime.
You want a new page.
Yeah, you could then flush your cache. Yeah.
Okay, that's
Yeah.
good to know. How can I see my Varnish settings in Pantheon?
The Varnish settings are the same for everybody. So you can use that debug tool that I
You can change the time just by changing your Drupal cache.
Yeah.
I Drupal. I thought, because when I talked to somebody, they were like, "Oh, Pantheon just ignores everything you have in your cache configuration."
Not every-
Not quite.
Not quite.
Yeah.
Okay, so if I just extend it.